purchased a very inexpensive linear variable power supply from eBay in a kit form, and I thought I'd do a video on the construction of that kit. We can look at some of the components, measure some of the components, the quality of them, and then after the construction is complete, in a second video I can test it with a couple of different loads, a simple resistive load, and then we can try and put a slightly more reactive, so maybe switching power or something along those lines. And we can look to see how good the regulation is, the load regulation, etc. So I hope you enjoy this one. If you'd like to subscribe to the channel, please do so. It's always highly appreciated. And leave any comments in the comment section as related to this video. So let's go. So this is the kit, delivered in an anti-static bag. I don't know if you can see here, it's 0 to 30 volts and 2 milliamps to 3 amps output. Required a 24 volt AC supply for the maximum of 30 volts, but obviously if you just want to use it as a 5 volt supply, you can go with a much lower AC voltage, somewhere typically I'd say that 8 to 10 volts. Here's the label from the kit. I can put a link in the description for where I actually got this from. I'm sure there are many sellers on eBay of exactly the same kit. So let's go ahead and open the kit up and see what's inside. Let's have a close up look at the PCB to start with. I shall do that right now. Give me a second. So as we can see, it's a double-sided PCB. The quality is actually pretty good, I would say. The through-hole plating looks good. The holes are drilled nicely. The mask is good. So let's look at the components. We'll open up one bag at a time. So here's the first one. So we've got a 3300 microfarad 50 volt electrolytic, signal diode, 3 ceramic bead caps, got a S9015, an S9014, a D882P, got a 5 watt 0.47 ohm resistor, 10 mic 50 volt, an LED. In the second bag we have heatsink, the D1047, a totally unmarked 8-leg IC, useful, another totally unmarked 8-leg IC, and another totally unmarked 8-leg IC, hopefully they're all the same. 3 more ceramic bead capacitors. We've got a 10k pot, 2-pin terminal block, and a 3-pin terminal block. So here are the 3 mystery ICs. I assume that they're just standard op amps. I will try to find out what they are and report back later. For now, I will actually pop them under the microscope. So here we are under the microscope. As you can see, there is absolutely no markings whatsoever. In the next bag, we have two 3-wire plugs for 4 1M5408 diodes. The 7824 voltage regulator, 2 10k pots, 2 PT mode B mount plugs,
two 50 volt 47 mic electrolytics, a couple of PCB lamp pins, and 4 screws.
And in the last bag,
we've just got some resistors and some small signal diodes.
So at this point, I just want to go ahead and test some of the components. So we'll start with the electrolytic caps.
I'll put my meter in view here. Just get in a good spot so we can see it. Okay, so I'll start with the 3,300 microfarad 50 volt. See what this guy reads.
So should be 3,300. It's 2,900. ESR 0.3. That's fine. Capacitance is a little bit lower than I would have expected. Okay, next we've got 47 microfarad 50 volt. We've got 49 microfarad ESR 0.84. That's also okay. This is the second 47 microfarad, ESR 0.81. And the last electrolytic is 10 microfarad 50 volt. Oops. (9.5) ESR 4.5. That seems a little high. That's actually very high. I'm not happy with that at all. Okay, let me find another one. Okay, I've found another 50 volt 10 microfarad capacitor from my stock. Let's try this one. Okay, 10 microfarad ESR 1.22. That's much better. I will use that one, and I think I'll throw this one in the bin. So next up, I just want to test the ceramic bead capacitors. We've got a few different values here, so I'll just go ahead.
Test some of these guys. So this one is marked as 101, so that should be 100 picofarad. 107 is good. This one is also 101. That's 100 picofarad. Perfect. This one is marked as 331, so it should be 330 picofarad. 350, it's okay. Same again, 331. 360, that's a little high, but that should be okay. And next up we have a 104, so that should be 100 nanofarad. 107, yeah, that's okay. Next is 224, it should be 220 nanofarad. 235, good. And the last one is also, I believe, 224, 220 nanofarad. That's 234.
Next, I want to test the semiconductors.
So this is a E1047. NPN bipolar transistor going to 108. This is the 882. NPN bipolar transistor going 262. This is a probably a C331 or S9015. NPN bipolar transistor, okay. Second. PMP glycogen. So let's do that again. Going to 270. This one is an S9014. Again, going to 322.
And we've just got a few diodes to test. Might as well use this to test them.
Diode. 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 That's good.
I've got some small signal diodes here, which I will just test with the fluke meter. 0.61, 0.61, 0.61, 0.61. Tune. This one, 0.75. That reads a bit too high. That must be a Zener. It is. It's a 5B1 Zener. With the resistors, I've noticed that some of the color code markings are quite easy to distinguish. You can see here it's got some reds, purples, yellows, browns, but then others, well, they're terrible. There's very difficult to distinguish between the browns, the reds, and the oranges. So some of them are almost indistinguishable. So if there's any doubt with these, I'm going to have to measure them manually. I'll do that as and when. So next we'll just test the pots and the low ohm resistor. We'll do the low ohm resistor first. I can use my ESR meter to test this. That's fine.
So that's 0.49 to 0.47, so that should be fine. And next we'll just quickly make sure that the pots are looking reasonable. So if I remember, these are 10k. Yep. Yep. And I think it was 100k. Yeah, a little high, but okay.
So at this point I'm going to go ahead and just fold all the legs on the resistors. I'll do that in super high speed lightning motion. When that's done, I'll value them. So, see you in a moment. Okay, that's that bit done. Okay, I think I'm ready to start putting some components on the board. Some 10k resistors here. So we'll start popping these guys in. And I'll flip this over and solder those boys in. And next we've got a couple of 1Ks. And a couple of 27k. And a couple of 2k2. And we'll just solder these ones in at this point. Two 56k. And a 33 ohm. and a 4K7 and a 1K5. Next up is 82 ohms, 220 ohms, 3K9 and a 270K. That does leave me with a 100K left over. Can't see anywhere for that to go at the moment, but if I find it, I shall put it in later. And the very last resistor is a 2K7 1 watt. So next I'm going to fit the small signal diodes and the two Zener diodes. So we'll just go ahead and bend the legs on these guys. And we can go ahead and install those. We'll go ahead and solder those guys in. Next up, we've got a 1N4004 and 4 1N5408. So next we're going to install the ceramic bead capacitors. So we've got two that are 100 picofarad. We've got two that are 330 picofarad. And the second one, I'm actually struggling to find the place for the second 330 picofarad, so I'm going to leave that out for now. Go straight ahead and go to the 100 nanofarad, and then we've got two 220 nanofarad. And I'm struggling to find the second 220 nanofarad as well, so we'll leave that one out for now as well. Having just looked at the board, I can see that the op amps are actually marked on the board as being TL081. Texas Instruments, probably fake, I would imagine. Anyway, I'm going to install IC sockets where the op amps are actually going. So this is the tricky part in this operation. Next up, I'm going to pop in the 100K pot. Straight-ish. And we've got the two small transistors, which is a 9014 and a 9105. Next up, we've got the 0.47 ohm resistor, the three smaller electrolytic caps, next I'll put in the two 10K pots, and the LED. The heatsink next. The power plug. And the voltage regulator. Power transistor. Put plenty of solder on that. That just leaves the header for the fan. The main electrolytic capacitor. And the 2SD882. So that just leaves me to pop in the op amps. And there she is. So in the next video, we'll connect it up to some power and give it a good test and put it through its paces. Thanks for watching. Bye.